everyone, and welcome to this quick chat. Hope you're staying warm this winter. My name is Rod Walton, and I am Managing Editor of Microgrid Knowledge and Conference Chair for the Microgrid 2024 Conference, which is going to be April 22nd through 24th in Baltimore at the Marriott Waterfront. And I hope you can join us. And I am joined today by a microgrid and on-site power expert of the first order. And, you know, microgrids, of course, are just on-site power resources. And you really can't talk about power generation on-site close to the load without mentioning INNIO and its Jenbacher brand of engines. I mean, this is an incredible history that goes a long, long ways back. And it's even older than me, believe it or not, and way older than you, Robert. So I'm here with Robert Autengruber, who is Product Manager, Controls and Microgrids with the INNIO Group. And Robert, it's just great to have you. Thanks for taking the time to be on our Microgrid Knowledge Quick Chat.
Sure. Hello, everyone, and thanks for the invitation to this quick chat. Really appreciate it.
Yeah, you bet. So I mentioned the history thing a little bit in short related to Jenbacher, Robert, and just for those who might not know it as well, would you mind just giving us kind of the introduction into the INNIO Group and the Jenbacher technology?
Yeah, the INNIO Group is actually home for two brands. One is the Jenbacher, which is located in Jenbach in Austria. And there's also Waukesha, located in Waukesha in Wisconsin, US. And we also do have a facility in Welland, Ontario. So together we are more than 4,000 experts providing lifecycle support for more than 55,000 units shipped worldwide. And we also have a service network in more than 100 countries through our distributors and partners, but also directly. And as you said, yeah, well, those both companies have a long history. And the first Jenbacher engine was built in 1957. The first Waukesha engine was even built earlier in the 1930s, so almost 100 years ago. And our energy solutions now offer a wide range of standalone generator sets to complete solutions for power generation, for cogeneration, and also for tri-generation within a power range of 250 to 250 kilowatt to 1.6 megawatts. And the amazing part here is they operate on a broad range of energy sources, so from natural gas to hydrogen, but also biogas, biomethane, landfill gas. We support sewage gas and also other special gases as syngas. So we also have a long history of industry firsts that we're very proud of. And the most recent addition is the first megawatt scale hydrogen engine that can be fully run on hydrogen. So yeah, in short, also our mission is really to help industries and communities and of course our customers to master and navigate the energy transition.
Well, that's great, Robert. Thank you for that answer. And the hydrogen thing is really fascinating and amazing. You know, and we know that microgrids are just on-site power combinations close to the load with controllers to kind of unite it all and balance it all. But would you detail a little bit more on the difference between a basic and an advanced microgrid, and how much does that distinction matter?
Yeah, I think it matters a lot, and I'm going to details here a little. So there are numerous different definitions out there for microgrids, right? But especially for those who don't have an electrical background, those are not easy to understand for everybody. So what we found talking to the various people in the energy industry is that as soon as a plant is island mode capable, some consider it already to be a microgrid. And if that was our definition, we would have thousands of microgrids installed over the last 30 years, right? So why would we need to develop a microgrid controller then? So we found that we had to really communicate as an INNIO Group how we envision a modern and advanced microgrid. And for us, the main criteria is it has to address the global megatrends and challenges that we see as part of the energy transition. And those are decentralization, digitalization, and decarbonization. And of course, increasing electrification overall with e-mobility and also heat pumps coming up in some regions as well, one of the main drivers. So to address these challenges, right, we need sustainable solutions. So there should be at least one renewable energy resource in the mix of the microgrid. We want to have resilience. There should be one dispatchable unit in the mix, can be a gas engine or a diesel asset, and it needs to be economical, right? So this can be achieved by an advanced energy management system. So, and all of that also should be orchestrated and controlled by a smart microgrid controller. So to sum it up, what's an advanced microgrid for us? It's really a microgrid consisting of a renewable energy source, an optional battery on top of that. We have one reliable asset in the mix, and they are centralized, controlled by a microgrid controller. And on top of that, orchestrated and optimized by an energy management system.
Yeah, you made some important distinctions there, Robert. And following up on that a little bit, I'm just curious how you think the demand for microgrid solutions has evolved as we, from previous decades into now. And I mean, is that really more critical now, and why?
So I can definitely say the demand has increased. I see that on the daily rising number of customer requests that we get in. And I think for me, it's quite simple, right? The demand of the microgrids is depending on the rising share of the renewables in the energy mix. And this is what we see around the globe. And that's also why this applies for all of the different markets, essentially. So for me, the microgrids will become more and more the standard in the decentralized power generation in the coming years, and not an exception.
Right. There's a real important business case in the value chain to be made there, and we'll get into that a little bit later. But I want to talk about this INNIO360 Energy Lab that's near the home base, right? And there's a lot going on there. I mean, we could spend a whole conversation on that, I think. But just highlight to tell us why INNIO did it. Is it completed? Is it operational? Where do you see it going? And what future opportunities are there for the work at the INNIO360 Energy Lab?
So INNIO360 Energy Lab, we really modernized our boiler house, right? Where we had 4 traditional gas-fired boilers that provided heat to the facility. And in 2015, we made the first steps where we installed the first CHP. A couple of years later, we installed a second one. We also added a power to heat module, later on PV on the roof of our production facilities. And we also added a battery storage system. And there's also still a small water turbine, a very old one, still in operation, providing energy to the microgrid. So yeah, the energy production at our side, we modernized it also to support the energy transition. And I think these are the challenges that also a lot of our customers face. So now the Energy Lab is really a dual purpose. First is that we want to demonstrate the energy transition at our site with a microgrid controller under real commercial and real marketing conditions. And so it's not just a technology demonstrator, because it must be operated economically. It must provide electrical and thermal energy to the entire facility. So we are our own customer, so to speak. And in addition, of course, the INNIO360 Energy Lab gives us also the opportunity to test new software development and also to test potential customer configurations at our facility. We'll also expand the Energy Lab too in the future. We'll add 2 megawatt electrolyzers and also hydrogen storage in a later stage. And for us, the Energy Lab is really where we are building the energy systems of the future.
Wow. I mean, spot on, Robert. Research and development are the keys because, as you talk about with things like of the future, like hydrogen, energy transition is not just about where we're at right now, but where we're going. And so let me kind of just pick your brain here a little bit around that and around the microgrid. But what are the factors that are crucial to making a microgrid successful? And I mean, they can be the financial elements, the sustainability, resiliency elements, and how do you define success going forward?
Yeah, so every microgrid is different, right? Some say microgrids are snowflakes. So the business case is really unique to the use case of the customer. And So the most important thing is to understand really the customer requirements, and it starts with the load profile. And as you might know, that sounds trivial, but it's not, and we have to help a lot of customers there at that end. So working in close cooperation with the customers is really key, and there are a few important considerations to make. Right, one is what's the maximum size of renewables that you can integrate? How important is resilience for you? What are the production losses in case of an outage? Is it part of the critical infrastructure? Do we need to build in redundancy in the controls? All of these factors. And let's make no mistakes. Microgrids are complex solutions, and really thorough planning of the microgrid is really critical for the success. This is why we also decided to support in planning and sizing and with energy consultancy, and as a service to our customers.
Yeah, great. Well, I mean, cost benefit analysis, right, is always first up on the investment side historically, but are the value drivers simply the same as they've always been? Or is the microgrid equation really offering something different for the future? Should we be thinking about it differently?
Well, let me quickly touch on the value drivers. So the high-level value drivers for the microgrids, I would say. The first is renewable integration, right, with PV, as renewables have the lowest levelized cost of electricity. Then there is peak shaving or some kind of supporting the grid and ancillary service that can also reduce electricity cost. Then there's energy arbitrage, right, which is mainly enabled by a battery storage in the first place. That's also a very important revenue stream to increase the ROI of the microgrid. Then there is optimized self-consumption by storing excess renewable energy that you can use at the later stage, for instance. And then you have in general power reliability and resilience. And I think the main value drivers will remain the same, but there are new developments that will also bring new opportunities, right? When I just think of the growing prosumer market, or I think there will be more focus on managing the demand side rather than just the generation side of the microgrid. I think there's huge potential in this area as well. And then, of course, e-mobility with e-charging, and also in the next future step, then bi-directional charging with this EV units. I think those are the three main trends, I would say, in the near future, also impacting the value drivers of the microgrid.
Right, the bi-directional thing is huge, and I'm looking at like the different work going on in California, different places where you can almost turn the EVs into mobile microgrids and that kind of thing. So that is really a fascinating part of the future developments. Robert, your teams have done a lot of research and work into evolving the INNIO Group's Jenbacher microgrid controller, which is just a sign of how much this historic company itself is changing. And just tell me what you've learned and where does it stand now?
So for us, the microgrid controller is really an expansion or a so-called an add-on package to our master control that we've been offering since more than 20 years. And that's a product that was really driven purely by customer requests. And I think that's also made it so successful. It all started with when customers wanted to run multiple units in island mode operation and that are also black start capable. And when you perform a black start, you need to define the first mover, otherwise you have a short circuit, right? So we developed the logic around that, and then further improved it also to manage larger microgrids. Many features were also added over the years, like load management, import-export control, controlling the mains breaker, coupling breakers, or interfaces for ancillary services. So and the same goes for implementing renewables for us. It's just an evolutionary step that we made to our master control that made it an advanced microgrid controller. And yeah, we launched the microgrid controller over a year ago. And so far we have very positive response from our customers. And so really looking forward to helping our customers in their microgrid planning and also in the execution in the near future.
So energy management technology is at the center of making it all work. You know, INNIO has this My Plant optimization platform. Could you tell us a little bit more about that and why improving the operational efficiency of microgrids is just a continuing challenge and so key to the future?
So the MyPlant digital platform actually hosts two main solutions. One is the so-called MyPlant Performance, is an asset performance management tool where we have almost 60% of all the units shipped worldwide connected. And the APM is actually a tool where we provide remote support, we provide advanced analytics, reporting function, predictive maintenance as well. And the MyPlant Optimization is our energy management solution that builds on that proven MyPlant platform. And this is where we further can optimize the microgrid. And we talked before about the value drivers and the business case of the microgrid. And there's another layer of complexity on top of that. The parameters in this business case are changing dynamically, right? Just think of changing electricity prices, changing fuel prices, changing weather, of course, that impact the renewable power generation. And there might be other operational or regulatory requirements that you would want to consider as well. So the question is really how to operate which DER to achieve the lowest levelized cost of electricity possible. And as the complexity increases, this gets more and more impossible for a human operator to manage. So this is where really the machine learning-based energy management systems shine. Because in essence, what they do, they generate an optimized operating plan for all the DERs connected in the microgrids. At the same time, precisely understanding the operational requirements for the entire plant, and also giving the operator the opportunity to improve the decision-making process. And of course, they can always change schedules or operating plans if needed. So in an essence, if we want to improve economics with this increasing complexity that we see, then I think an advanced energy management solution is absolutely key.
Yeah, and you know, and it is a business. I mean, there's environmental goals, and obviously there's, you know, financial responsibilities and all of that. So kind of as we wrap up, Robert, could you just kind of highlight for us, with all this work that you guys have put into it, the unique selling points of INNIO's Jenbacher microgrid solutions?
Yeah, of course. So the Jenbacher microgrid controller is really built on the vast experience that we have with plant controls in general and island mode operation, as I mentioned before. So it's really a proven product that has been updated. It's also based on a very feature-rich master control that we offer since 20 years. So we really offer that all-in-one microgrid control solution. And we talked about optimization. MyPlant Optimization is definitely also a differentiator for us compared to some other CHP OEMs and also microgrid controller suppliers. Also on top of the master control, there's no additional hardware needed. It's really an add-on software. So it's a single-stop solution from an established OEM. And another thing I would like to touch on is, although we offer our own microgrid controller, right, the Jenbacher engines are supplier agnostic, right? So of course, we would also help customers if they desire to use another microgrid controller from another brand. We're really happy to help them to standardize the interfaces so they can be better integrated.
Right. Wow. That's fantastic. You know, it's fascinating to really kind of study and learn how much, you know, these companies have adapted with, you know, once traditional and legacy type technologies like this, and changed and evolved in the next gen players, you know, on microgrid, energy management, renewable fronts, and that kind of thing, all kind of in service of the commercial and industrial energy transitions. And I really gained a lot from this conversation with Robert Autengruber, who is product manager, controls and microgrids at the INNIO Group. And Robert, thank you again very much for all of those insights.
Thank you as well for having me, and really looking forward to see you in Baltimore at the Microgrid conference in April.
Yeah, absolutely. I hope you can be there. I hope you can all be there. I want to say thanks to our audience for watching with us, and hope you've gained a lot today. I'm Rod Walton. Thank you very much. Stay warm and goodbye.